Look at this example. It has fractions, and I know what you're thinking right now. Fractions suck. But you know what? You're right, they do. The good thing is that we can get rid of them. And once we get rid of them, you're back to ground that you're comfortable with, and you can solve this system quite easily. So let's get rid of these dreaded fractions first, and we're going to look at each equation one by one. So starting with the first one, I look at my denominators and I say, okay, I have 3 and I have 5. So I have 3 and 5. I want to get rid of these numbers. So first, I need to ask myself, what do 3 and 5 divide into? Well, they divide into many numbers, but specifically, the lowest common multiple of 3 and 5 is 15. So here's what I'm going to do. I'm going to multiply both sides of this equation by 15. And the left-hand side, I have to multiply 2 terms by 15. So here's what it looks like. I put my 15 down. My first term is x plus 4 over 3, close bracket, minus 15 again, y minus 2 over 5, close bracket, equals 2 times 15. So I've multiplied everything by 15. Now I can start doing some simplification here. Here's what I mean. 3 goes into 15 5 times. 5 goes into 15 3 times. So what you're left with essentially is an equation with just brackets. Minus 3, and then I have a y minus 2 here, is all equal to 30. So to simplify this, well, just multiply the 5 in over here, the negative 3 over here, and let's see what we get. We have 5x plus 20 minus 3y plus 6 equals 30. And if I collect like terms, I end up with 5x minus 3y equals 4. And all I've done is I've brought the 6 and the 20 over. It's 26. Subtracted from 30 gives me 4. So that takes care of our first equation. Now let's turn our attention to equation number 2. Again, those dreaded denominators we want to get rid of. So I need to find the lowest common multiple of 5 and 2, which in this case is 10. And the same thing I did in the last one, I'm going to multiply both sides by this lowest common multiple, so that what I obtain is 10 in brackets, 2x plus 5 over 5, close brackets, plus 10, open bracket, 2y minus 4 over 2, close bracket, equals, what is it, 10 times 8. Same thing, I look at how many times 5 divides 10, the answer is 2. I look at how many times 2 divides 10, the answer is 5. And then 10 and 8 will give me 80. But let me write down the next step first. So I have 2x plus 5 times 2y minus 4 equals 80. Multiply this 2 inside, the 5 inside. I'm left with 4x plus 10 plus 10y minus 20 equals 80. Collecting like terms, 4x plus 10y, and then if I not subtract, but if I add 20 to the other side and subtract 10, I'm left with 90. So there we have it. We have our two equations, and they are without fractions. So this is good news. I'm going to take these equations now. I'm going to bring, oh, not that. I just want the equation part. So let me carefully delineate that equation. I'm going to bring it down here. And I'm going to do the same thing for this equation here. I'm going to pick it up and I'm going to bring it over here. So these are my two equations. Now, I can use the method of substitution or elimination. Substitution is usually a good idea when you have a variable with a coefficient other than, when you have a coefficient of plus or minus 1. Now, in neither of these cases do the x or y's have coefficients of plus or minus 1, so I think I'm going to use elimination instead. And I think the variable I'm going to eliminate for this one, let's keep it simple. I'm going to look at the coefficients of the x's. So I have 5 and 4. In this case, the LCM of 5 and 4 is 20. So I want to make this 5x into 20. I want to make this 4x into 20. So I have to multiply each equation by the appropriate factor. So my first equation becomes, let's see, 5 times 4. So 5 times 4 gives me 20x. Negative 3 times 4 gives me 12y. And then 4 times 4 gives me 16. And for this equation, I have to multiply the 4 by 5, so I'll get 20x again, minus 50y equals 450, because 90 times 5 is 450. So this is good news. Let me take this work here, and I'm just going to copy it and paste it down here. So what operations shall we perform on these two systems of equations? Should we add them? Should we subtract them? Well, this is positive 20 and this is positive 20, so if I want to get that equal to 0, I need to subtract. So my x's disappear. Negative 12y minus negative 50y yields a value of, what does that give us? 12, that'll give us, 38. So 38y. There's a mistake here. So this was supposed to be positive 50y, and that makes this positive 50y. So this is not 38. This is going to be negative 62y. And that equals negative 434. So at this stage, I can divide both sides by negative 62, and this yields y equals 7. So that's good. I'm going to take this 7 value now and substitute it into one of the original equations, and I'm going to look at specifically these equations here because I certainly don't want to work with any fractions. I mean, if I wanted to, I could plug the y into one of these two, but I'm not going to bother. So I'm going to pick, say, this first one here. So I have 5x minus 3 times 7, again I'm replacing y with 7, equals 4. So that's 5x minus 21 equals 4. That's 5x is equal to 25, which means that x is equal to 5. So our point of intersection is 5, 7. There's your entire question, top to bottom. It is very involved, I agree. The hard work is maybe at the beginning just setting it up, but once you get it down to a recognizable form, it's just applying simple versions of elimination or substitution.